All right, so if you recall last cycle when we did sine law, we talked about looking at triangles to solve for unknown information that aren't right angles. You did this in grade 11. If you took academic, you even did these in grade 10, right? So you've seen this stuff a lot of times before. Cosine law tends to be the one that trips people up, and it tends to be one that we need the occasional reminder for. So before we do that, I'd like to mention that if you want to know how it's mathematically arrived at, I'm not going to do that with you as a class because it's kind of complex and it can tend to make people check out. It can tend to make people get confused. But if you're curious, it's a really fun proof. So I'd love to show you. But I'm not going to show you here. Anyway, for some triangle, if we called this vertex A, that vertex B, and that vertex C, how would we label this triangle? Hello, sir. There you go. Do you need a pencil? There's one here if you need it. So if we call that A, B, and C, how would we, by our standard practice, label the sides of this guy? Yeah?
I'll label the opposites with lowercase of. Yeah.
Cool. So the bottom here, what would it be called?
That'd be lowercase b.
Very good. Ms. Brown, what would we call this side here? Okay?
A.
Great. And no problem.
I can figure out whether it says nap time on the board.
Well, it's period 4 math class is nap time. Oh, I'm offended. I am offended. I may be boring, but you don't get to nap. It doesn't work that way, team. All right, and what do we call this side here? Oh, now I'm fired right up. You're getting all the hard homework problems tomorrow. See you nap through that. What do we put here? Good. All right. So there we go. So for any triangle ABC, I want to imagine that we wanted to figure out the length of side A. Say we knew everything else. The only thing we didn't know was the length of side A. Does anyone remember the cosine law, how we would find that? It starts out looking a lot like the Pythagorean theorem. We would say a squared equals Pythagorean theorem. Think Pythagorean. B squared? Yeah. So here, if we were looking for C, it'd be A and B, right? So it's like the Pythagorean theorem, but the Pythagorean theorem only works if the triangle is right angle. And this triangle is not right angle, right? It would have to extend up like that if it were to be right angle. You don't need to draw this, but does that make sense? This would be the right angle triangle. So this is like a right angle triangle that is missing a piece of itself. Does that make sense? So A, in this case, is it longer or shorter than it would be if it were a right angle triangle? Shorter. So we're going to have to remove some of this. B squared plus C squared would make it too big. Does that make sense? So we have to remove from it. And again, I can show you the math another time, but does anyone remember what it ends up being? It's A squared equals B squared plus C squared minus... Yeah, not AC in this case. In this case, BC. Yeah, but yeah. And then times. It's the cosine law. What haven't we used yet? Cosine. So here's its big moment to shine because it's 2BC times the cosine of the angle. Good. So that is the cosine law.
You get the minus 2BC. That's throwing me off.
All right, so that's the equation. Where it comes from, I can show you. It's actually just geometry. Basically, this here can be worked out by figuring things out about this triangle.
So it'll be that every time.
It'll always, that's right. Now, here's what I want to note. We always have to put the side that we're looking for in front. And we always will match it up with its own angle at the end. Some teachers will show you all three versions of it. They'll say a squared equals this. Then they'll set up a second equation for b squared equals, and then another one. I think that's stupid. Because the a's, the b's, and the c's don't matter. Right? You could use any letters you want. You could make your triangle L, Q, Z, and you should still be able to come up with a cosine law. Does that make sense? If the triangle had D, E, and F, you shouldn't be like, well, I've never seen this before. I'm going to give up. So the letters aren't what's important. Here's what's important. We start with the side we want to know. And then do we ever use that letter again in the middle here? We use the other two sides. Then we use the other two sides. Do we ever use this side again? No. But at the very end, we use the cosine of its angle. Okay? So it's a squared equals b squared plus c squared minus 2bc times the cosine of a. The only time we use a is at the beginning, because it's what we're finding, and at the end, because we have to use its angle. Because how big the angle a is tells you how much of this section gets cut off. That make sense? By the way, if this were 90 degrees, the cosine of 90 is 0, and we would cut none of this off. But there it is. That is our equation. But again, it shouldn't be limited to A's, B's, and C's. You should be able to do it with anything. So I want you to make two triangles. I'm going to draw the triangles. And I want you to label them with any old made-up letters. Don't use A, B's, and C's. And I want you to write a cosine law to find how long this side is and how long that side is. And I don't want your letters to be A, B, and C. Does that make sense? So I want you to write one down here and one down there, but I want you to use random letters because I do not want us to be limited to only being able to do this if the side we're looking for is A, B, or C, or even worse, only A. You've got to be able to write a cosine law for any triangle you come across. I forgot to have my drink at lunch, so I'm going to have it now if that doesn't offend you.
I'm offended.
When I said if that doesn't offend anybody, I was largely being polite, and I'm just going to have my drink.
I'm still offended.
I'm surprisingly okay with that, because I sip my delicious, delicious Perrier. Perrier actually isn't delicious. It's just one of those things we convince ourselves we like as we get older. Like coffee or children.
I
would like coffee, but
If we
children
went
I
back
can
there, would it matter if you were like,
No, the order makes no difference. So if C came first and B came second, doesn't matter. Yeah. Yeah, usually by convention, we put those two in alphabetical order, that doesn't actually matter. What matters is that the one you're looking for is out front. You can only use the other two sides in the middle, and at the very end, use the angle on your side. The y is the one you're looking for. Okay. This is all good, just so you know. You can't have that in brackets. Yep, no problem. Nothing wrong with that. Nothing wrong with that at all. But just. Like I said, you have to subtract all of this. Yeah,
Is this related class?
it is.
So is Karen Shannon in class?
Sorry?
Karen Shannon?
Yes, she is.
Could she come down to the office, please?
Yeah, she's on her way.
Thanks so much.
No problem. Fancy? That's great. That's good. Next. H, I have J, so it's good. Yeah, that looks great. Good job. And you're looking for N. Yeah, perfect. That looks great. And what? Looking for C. C equals L space plus L squared. Yeah, well, that's great. Y is if I could squared. That's good. That's good. Yeah, and C, couple, right? Yeah. So that's great. Good.
Well, I haven't made my second one.
That's okay. I think we're this one.
Yeah, I was just talking. But I got that.
That's good second. I'm looking for H. I squared plus J squared. I J and H. Fantastic. Good job. I pick what? That one. A squared plus that. Oh, right. Okay.
This is X, right?
Yeah,
I got X, but
Yeah.
I still made my A.
We're looking for squared, yeah, plus F squared, minus BF, yeah, perfect. And here we're looking for E, so it's E squared plus C. Good. Well done.
After.
All right, so everyone seemed good with that. I'm going to cats, dogs, pigs. All right. I agree. All right, what would this side be called? Little pigs. And of course, I'm looking for the little pigs, which I think makes me the big bad wolf. This side would be, haha, I'm here all day. Tip your waitress. What's this over here? Oh, I like it. Okay. Oh, and kittens. Yeah, I like it. So there should be piglets, really. Okay. Well, we didn't come up with the pun until the second one. All right, so here we go. All right, there we go. So this is the strangest triangle I've ever solved for, but okay, so be it. I am looking for piglets. So what is true here? Piglets squared is equal to what? Talk to me. Help me out here. Okay, so puppies, the square of puppies.
Plus
Yeah.
the kitten's square.
Good. Minus 2 puppy kittens. Very good.
Well, actually multiplying that. But
Yeah. Times. Cosine of? Pigs. Very good. Very good. All right. The letters don't matter. They do not matter. What matters is that the side you're looking for is here, its matching angle is there, and everything else are the other sides. And as Kayla noted, the order of these things is irrelevant. In addition, does the order matter? No. 2 plus 3 is the same as 3 plus 2. The order doesn't matter. In subtraction, it matters, but in addition, this order is irrelevant. In multiplication, does the order matter? No. 2 times 5 is the same thing as 5 times 2. In division, order matters. It's because division and subtraction aren't real, they're just fake. It's true. Subtraction is just adding negative numbers, and division is just multiplying by fractions or by decimal numbers. So. Not a conspiracy, but just that's why the order matters in those things, because they're made up things to make complicated concepts easy to understand.
You're saying math doesn't need them then?
I'm saying that I'm saying that math has them already. If you can add, you can subtract. They're the same thing. Like computers aren't taught to add and subtract. They're taught to add, and then if you want to make something smaller, you add a negative number. And so anyway. Okay, with that in mind, we can use the cosine law to solve for a side we don't know. So we'll do one together, and then I'll ask you to do it. I'm sure some of you super keeners are like miles ahead of me. That's okay. We'll do one together to make sure that we know how. Now, you might note about this that it's not labeled. Let's go ahead and label it. If this side is little x, what should I do? The big X like that? Very good. So that's going to be big X. And then the others can be whatever I want. What do you want to call this angle? Okay, in which case we'll make this side Y. Great. And this side will be this down here, little y, and this down here, little z. Good. Is everyone okay with that cursive z? Cursive z is nice. A nice looking letter. All right, so what are we looking for here? We're looking for x. So how are we going to find that? What's the cosine law for this triangle if we're looking for x? Yes, sir. Yeah, listen, the worst thing that happens is you fail miserably, and then we fix it.
Little x, right?
Yeah.
X squared
Yep.
equals y squared
Mhm.
plus z squared minus 2 yz, I guess.
Yep.
And then I still cosine it.
Yep. Always cosine.
Times co, and then the big X.
Very good. Okay, so let's take a minute and try that. Plug your numbers in, see what you get. And I'll come around and say encouraging things. Yeah, I mean, that's going to be 97, right? Sorry?
We'll just do that.
That's really annoying. It's weird because I thought it was charged. Here you go, sir. Oh, Noah. I beat you up. Stickers on that. Stickers in your exhaust manifold. I don't even know if he has a car. When he gets one, there's sugar in the gas tank.
That's the most passive aggressive thing I've ever heard someone say.
I'm a little passive aggressive.
I'm like, so she's been my friend for how long, and that's the most aggressive thing?
She's a passive aggressive. You're a lot of things, but you're not passive aggressive. Passive isn't the word that comes to mind. That's great. Is it? Oh, it's great. Before you do the math, will you write that out there for me? I'm slowly training you guys, and eventually I won't even show up. I'll just leave you with the note and the computer hooked up and let you teach yourself.
That'd be fun. We'd probably do it miserably or very wellly, but I don't know.
I once had the flu and I didn't want to get anyone sick, so I taught from the science office at my old school. Hooked up the projector and a webcam, and I just taught from a different room. So I'm not coming out. Just walk the door. I can see them all. They can see me.
It's just a fundamental meeting.
I like you guys. No air quotes. They're good kids. Nice.
That one too is really fancy.
That is a fancy two. Good looking two. Thank you. All right, and let's go ahead and calculate that. See how we do. You know, I can't help but notice you switched to purple. Nice call. Yeah. There's pink in there somewhere. Do you mind finishing that off? I appreciate it. Yeah, don't use your pencil.
I won't use
They
my
won't
pencil.
see it. Only you.
You press really hard.
Yeah, there's lots of picture on the screen. Perfect.
You know, I have to say, now that I'm saying this, it's going to shoot something like crack or something. Knock on wood. I've had that thing for almost 4 years now, and the screen's really held up. It's like there might be a few little scratches,
Am I
but
putting
nothing
the answer
noticeable.
now too?
Yeah, go ahead and put the answer. Now, of course, once you've taken the square root, is it still squared? Use the eraser.
I didn't know that was a thing.
Oh, yeah.
Do you mind taking a look at this?
Well, let me ask you, do you have the same thing for this? Like, do we have the same?
I switched.
Why is that squared? These get squared, these don't get squared. Yep. And that's all. And bless you. So you must have got negative something.
No, the fourth. I should find very silly.
Yeah, right, yeah. Yeah, that's way off. All right, and you guys can try the one below at your convenience. It shouldn't. Let's see what's going on. Are you in radians?
No, I'm in degrees.
No, then you're good.
I did it that way, but maybe I have to do it differently.
What one are you on? This one here? This one here. Oh, okay, let's take a look. I want you to do this whole thing in one type in. Just type it in exactly how you see it there.
I always mess it up somehow.
Yeah. Oh, the calculator can be the hardest part, right? Getting it in there, but just exactly how you see it there.
I realize that because on all my tests, the only reason why they're not, most of my questions are right, it's because of the calculator is where I messed up.
There you go. Does that make sense? So your error was pure calculator, which is frustrating, but it's the kind of error you want to make. Well, now it's just pure pencil. And how are we doing? Did you get the same?
I got down to the part where I got to this. And I was just going down the list. I thought I was doing this wrong. And then I typed in the thing and I got the same answer. So I was like, okay, at least I know I'm going down the same steps.
Yeah, you're great. The only problem you're having, only error you made is you accidentally put this in as 20,
Thanks.
and it should be 22.
2.
I think you just didn't read your own writing.
Yeah.
Let's change that to a 2. Now press enter. There you go. Now you're the exact same answer. Does that make sense?
Yeah. We were taught with anything that's like larger than like 4 numbers times
Yeah.
down the list. That one's just easier to organize.
Right. I can see that.
Put this number in.
Already jump into the hard stuff, eh? What'd you say?
Seems like review, but
This should feel familiar. How we're going to make it harder this time is I'm going to give you 3D problems. The third dimension. No, you don't.
That's terrible.
False.
Terrible. There's no units on any of these. What letters do you want to use?
You can pick your units. You could say this is 146 cubits. Or centimeters. Or groundhogs. Maybe that's how you measure everything now. Maybe you make groundhogs line up, and it took 146 of them to fill that space. I don't know. And 88 groundhogs to fill the other. They would have to be identical ground. You'd have to clone them first and very carefully raise them to all be the exact same size. A lot of work, really, you're putting into that. But I admire that.
Are these all cosines?
Yes.
Do you use Coca-Cola for that?
How are we doing on the second one? You got it? Am I rushing anybody if we take this question up now?
What do we do? Yeah.
I'm rushing you?
Coca-Cola come in at all?
No.
When do we use that? It's like, I thought sine was like opposite over hypotenuse.
Because SOHCAHTOA is easier, and so we use it. We can only use it if the triangle is a right angle triangle. So there's no right angles to be had. And even this one that kind of looks like a right angle, maybe it may not be. We don't know. So you can't assume. It will. It will. The reason it works on a right angle triangle is that whole subtraction bit gets multiplied by the cosine of the angle. Well, if the angle's 90, the cosine of 90 is 0. You can just sign in the calculator. So on a right angle triangle, that whole last bit just disappears. And so it still works. Okay, so for this triangle, my time to shine. Look at me shining. All right, for this triangle, how would we label it? Since this is a lowercase h, I'm going to go ahead and make this, yeah, big H. And then after that, sky's the limit. You could call this
I used an E and an L.
E, and we could use this L. I'm going to assume that you're not sending a message about my class, because if so, you're not very good at spelling. This one here would be...
Sorry, I don't have a fourth letter to use.
And this one here would be L. Okay. I always just use the cursive L because otherwise it looks like a 1. You don't have to do that, but I always get worried that looks like I'm writing letter 1. Yes, sir. Yep. Okay, can I get a volunteer? What are we looking for on this triangle?
A number.
Specifically?
Side H.
Side H.
Usually a small number. But this is a massive one.
And does somebody want to give me the cosine law for this particular triangle?
Oh, E squared, sorry.
No, but yeah, obviously we're all different here. E squared.
Plus L squared.
Yep.
Minus 2L. Multiplied.
Cosine of H. Cool. Very good. Very, very, very good. All right. Well, I talked about that. Would you be kind enough to put your numbers in for that?
Yeah.
Thank you. I appreciate it.
I really went to work out an equation to spell out health.
Did you not?
I wasn't even thinking about it. Now,
I want to. Sorry, go.
Can while we do that, can we also just square root it at the same time?
If you want to put the whole thing under the square root sign so you do it in one step, yes. Nothing wrong with that. Absolutely, you can put a big old square root sign over the top of it. And when you plug into your calculator, press the square root button first thing you do. And yeah, nothing wrong with that. That works. I want to mention these questions I've picked where you have to use the cosine law. Because what's the other law we've used last cycle through? Sine law. And in one of the homework questions, you're going to have to use the sine law. It's the cosine law. In this case, remember with sine law, you always have to have, because you set up 3 fractions, you're going to pick 2 of them and cross multiply, right? One of those fractions has to have a number on the top that you know and a number on the bottom that you know, or you won't be able to cross multiply. And if you look at this triangle, there's no pair, there's no fraction where you know both, right? We know an angle and we don't know the side it's across from. And then you don't know the other 2 angles. So you don't get a complete fraction, which means sine law won't work. You won't be able to get an answer. When you try to cross multiply, you're missing information. You can only cross multiply if there's one thing you don't know, and when you try to cross multiply for this, there's 2 things you don't know. That doesn't work. We don't have a way to solve that. So for this question, you have to do the sine law. And when you go through it, you end up with H. Did I say sine law? Ah, failure. The sweet, sweet smell of failure. So when we do that, this all looks lovely. We end up with a side of 116.6. Does that look reasonable? Yeah, looks good to me too. I'll snag that if I can. Now, in all these cases, we've been finding a side. In the next, we're going to ask to find an angle. And I'm going to show you the algebra. And the algebra will always work, but it's not how I'd recommend doing it. So if we remember, if I was looking for side A in a triangle ABC, it would be a squared equals b squared plus c squared minus 2bc and the cosine of a. Okay, now if I wanted to find the angle instead, what do I want to get by itself? This, right? So first, what do I have to move? I almost wish I'd left myself a bit more room to do this. I think I decided I wasn't going to show you the algebra this afternoon, and then I changed my mind, which is my prerogative. What I would say is if we want to get cosine A by itself, I've got to get rid of this b squared, so I can subtract it away, right? And I've got to get rid of this c squared, so I can subtract it away. Can I just subtract away the minus 2bc? Or in this case, add it away because it's already subtracted. Will that work? Problem is, b squared's being added to cos A. C squared's being added to cos A. But what's this negative 2bc doing to cos A? It's not being subtracted, actually. To cos A, it's being, I'm going to divide it. Right now, it's being multiplied. And so for this to work, I have to divide it by negative 2bc. Does that make sense? And what I do to one side, I have to do to the other side. And when we do that, we end up with this. We end up with cos A being equal to, now it would be, I'm going to show this to you in 3 steps. It'd be a squared minus b squared minus c squared. That make sense? Over, what did we divide by?
BC.
Yep, almost.
Oh, negative 2.
Very good. Over negative 2bc. Okay? Now, that's not quite the final because there's just a math manners thing here, which is we don't like to have a negative sign in the bottom of a fraction. And so to do that, we're going to divide top and bottom by negative 1. So everything's going to switch signs. So the 2bc, instead of being negative, will now be positive. But everything's going to switch signs. So the b squared, which was negative, is going to be positive. And the c squared, which was negative, is going to be positive. And the a squared, that used to be positive, is going to be negative. And I moved it to the end just because I don't like to lead off with a negative number. I'd rather put the 2 positive things first and then put the subtraction at the end. That's just a nicer way to write it. And this is the cosine law to find angles. All the stuff on the left, I will never ask you for. You don't need to show it. I just want to show you where this comes from. Does that make sense?
Question, is the a on the end supposed to be squared or instead?
I think it is. I think, look again. Yeah, it's squared. Yeah, it's totally squared. Try to pay attention. And I want to mention something. I'm going to write this. I'm going to do one thing more. Ready? I am going to put the top in a big bracket, and I'm going to put the bottom in a big bracket. Now, mathematically, those brackets aren't necessary. But when you need them is when you go to put them into your calculator. Yeah, because otherwise what it thinks you're doing is it's saying take b, square it, take c, square it, then subtract a squared divided by 2, then take all of that and multiply it by b, then take all of that and multiply it by c. Your calculator doesn't know that you're trying to make a big fraction. So you have to tell it. And the way we tell a calculator we're making a fraction is we put everything on the top in a big bracket and then divide, and everything in the bottom goes in a big bracket. Okay, now, let's take a look at this. Because just like last time, I don't want you to assume that it has to be A, B, and C. The angle we're looking for goes out front. Where's the only other place we see that angle? It's the one that gets subtracted. the angle we're looking for lines up with the side that gets subtracted. Does that sign show up in the bottom when we multiply? No. Okay, so before you do the question, look here. Look here. You can sketch this somewhere, maybe on the back, maybe on a piece of paper, whatever. But just really quickly, Q, give me a letter. F, give me a letter.
You.
F me. M it is. All right, so how did I know that was coming? I want you to tell me then what the cosine law would be if we were looking for angle Q. All right? I want you to be able to do that. So take a minute and write it out. The cosine law to find angle Q. Not side Q, angle Q. Do I have a volunteer to write this guy out for me? Perfect. I'm going to put my appendix in. Any of the stories.
Did you forget to do the attendance yesterday?
For weeks.
Oh.
Whole semesters sometimes. No, I did yesterday's attendance.
You did?
I
wasn't here, and I didn't get.
I noticed this morning that I had something like 2 absent when I got my attendance verification.
You didn't mark me absent.
Yeah, that's what I mean.
Yeah.
Because every day we get an email saying please return.
It doesn't matter anyways. It goes straight to me.
Yeah. Oh, does it go straight?
It goes straight to me because like I'm on my own right.
You tell yourself off then. You go, Kayla, I'm very disappointed in you. And you go, I'm sorry. That looks great. Well done. Okay, now let's use this to actually do a question. That looks really, really good. Did anyone get anything different than that? It should be the cosine of Q is f squared plus m squared minus q squared. That's a numerator. We're going to put it in a big bracket when we use our calculator. Divide by 2fm, which we're going to put in a big bracket. In fact, that's the really important one. If we forget to put it in a bracket, we'll be screwed. And they're calling this alpha. They're using the Greek letter, but I'm going to call that angle A. I'll call that A. I'm going to call this
S.
S.
And Z.
And Z. That's not even a word. I don't know what you're going for. Zaz. Come on. Zaz. All right. How are we doing, sir? Can I see? Oh, that's good. Where'd you cross out? Oh, because you used the side formula.
Yeah.
You need to retry it with the. All right. Well, we'll do this one together. Can I get your attention up here? We'll do one together, then I'll set you loose on one on your own. What is going to be my angle formula for this? Alexis, do you want to try it, or you're okay? All right. No problem. Kendra, you want to give me the equation for this one?
squared
Yep, which in this case is, oh, you're right. Yep, z squared.
plus a squared.
Which one gets added?
Oh, sorry. C.
Yep.
S squared.
Yep, perfect. In your case, C, no problem. And then what do we do with A?
And, minus
Very good. Minus A squared.
and it's over 2.
Very good. Very good. All right. And if I go to actually put the numbers in, Ms. Spirinello, can you give me the numbers for this up top? Geez, is that squared? No? Okay, what is it?
19 squared.
19 squared.
9 squared.
Very good.
Divided by 19.
Yep. Very good. And we're going to be sure to put big brackets around that, right? And I know this may seem pedantic or like I'm really, really, really hitting away at this point, but I find that like 90% of people who get a cosine law question wrong get it wrong because they plug it into the calculator wrong. We're just going to take our time and watch how we put this in. And I just like to show off my calculator. Isn't that nice? I don't even want to tell you what Texas Instruments charges you for this stupid thing. A lot of money. Okay. No. I think it was like this stupid emulator. A single license is like $180. So we just bought one license and then we made a lot of copies of it. Isn't that obscene?
Yeah.
Yeah.
When you could just use them.
If you ever want to make a fortune, become somebody who develops like software for education, because you can just charge whatever you want. The school boards are like, okay, we'll pay that. That makes sense. Anyway. Okay, so how am I going to plug this in? I start with a bracket for the whole top. And I'm just going to put it exactly how we see here. 19 squared plus 9 squared minus 16 squared. But then what do I need to do? I need to close this bracket. And then, how do I make it a fraction? I divide, and then I open a bracket. The whole bottom goes in a bracket. And then 2, I could use the multiplication button. But if you've written it in brackets, you can match that exactly. Nothing wrong with that. And there we go. And when I do that, I get some stupid little decimal. 5439. Is that the answer? Is that angle A?
Yeah, if you want to do close minus 1.
Excellent.
And that will be there.
Very good. So that will actually give me the angle A. So don't forget, that's another thing that we see a lot. Somebody does all the hard work, and then they get this and they're like, I've got the angle. The angle is 0.5439. And it's like, come on, look at that. Look at it. Use your eyes. Open your face. Is that angle 0.5439? But we just skip it. We get so excited because our calculator gave us a number. We're like, I'm done. I got a number. So don't forget to cos-inverse it. And for the super keen amongst you, if you are of the super keen variety, somebody asked me last time, could I just square root the whole thing as I go? Yeah. What could you do with this whole thing if you want to? You could, the first thing you press could be cos-inverse, second function cos. That works. Hey, when we do that, what angle do we actually get?
57.1.
57.1 degrees. Make sure you get that. All right, you guys try the next one, and I'll go around and say supportive things. Like, I think you're doing great, and hey, you'll always have English class. That's what my math teacher said to me, I'm sure. I'm kidding. I would never say that to some of you. Do you? Are you not an English kid?
I can read it paragraph.
I always find I don't even attempt to read books during the school year because I always find like I read a page. I love to read. I'm a reader. But no, during the school year, I've always got so much on the go that like I'll steal time to read a couple pages of my book, and then the next day when I go to like grab it again, I'm like, I can't remember what I read yesterday at all. And I'm like, who is this character? I've never heard this name. That's good thinking. So I don't even try to read during the school year. I read a book over the March break, and I was quite proud of myself. Nice. I attempted to read a book in French once. I thought I was going to enrich myself by really helping my French language skills. It was a pathetic experience, let me tell you. I did not learn a thing. I mean, I guess. And then for a class I took once, I read the first 10 chapters of Dante's Inferno in Italian. And that was also, I can still recite the first line, like Nels Martita de Notre Vita era smarta por un selva oscura. And oh, come on. I can do this. I can do this. I can do this. Oscura. Oscura. Oh, now I gotta look. Okay. Nel mezzo del cammino di nostra vita, mi ritrovai per una selva oscura che la diritta via era smarrita. Ahí quanto a dire che era e cosa dura. Esta selva selvagia e aspera e forte che il pensiero rinnova la paura. And that's all I used to have memorized.
You have to add some room to that.
I can't. I am physically incapable of rolling the R. I can't do it. Man, did I try. Voice just won't do it. No matter how hard I try.
You just can't roll. No, I
can't do it. Man, I took Italian class, and she'd be like, she would do it and be like, no, you, and I'd be like, and she'd do it again, and I'd go, and then we would do this for a while, and she'd go, it's okay. You just don't worry about it. Okay. Okay, thank you. Thank you, Connie. Sorry? Yeah, no, I'm.
I learned to say there's no word please.
There's no which?
Word for please.
Wow.
That's super annoying. So then, okay, yeah, the limit. The word for please. Everyone
I just use it in my bag. Thank you. Yeah. Oh, yay. That's what I'm thinking.
It's so
Okay. May I ask you to label the triangle and set the law?
Okay.
Don't solve it, but just label the triangle and set the law.
Okay. Okay, so let's see here. Slowly. Okay. Oh, thank you. It's crooked. I have the time, so.
That was round off.
Not like that one. That's a bit. Okay.
But because the transit doesn't translate English correctly.
Was it like all over the place?
Yeah, so I had to find an English teacher and then translate the words correctly. And it took me 45 minutes to do that.
Wow. We good?
So I'm doing that.
And let me look. My eyes don't work at the speed of light.
What?
That
Oh,
looks
so
great. That looks great. Okay, let's see.
It's funny.
Thank you.
I love it.
Goodness.
Okay,
Whenever you
so,
And
okay,
unfortunately,
so
you
I feel like
we're
writing
gonna
my
do
name,
all
so.
in one step.
How do you do that?
The problem is this won't work because you needed two brackets. One to say take the cosine inverse of this whole thing, and then the next one to say I'm still. So exactly what you did,
Yeah.
but two brackets.
I knew it had something to do with your name, but I always forgot what you, like your middle name was.
Yeah.
There. And at the
I'm not going to rewrite it. I'm just erasing.
That's right. Yep.
So then
If you do
when
that,
I get down here, I'll put
you'll have
three.
That's right.
Awesome.
I do my twos like that.
Mm-hmm.
I got it is a face.
I got a syntax here, so.
No, no.
Oh, that's good.
It is hideous. No. Okay.
I didn't have the required number of brackets.
No, not I.
I thought you were doing it on your phone somehow.
Erasing it. All right, I'm done.
Oh, you look good.
Because it is glitter. All right.
Good afternoon, East Illegal. As you probably already know, tonight is parent-teacher interviews. And in about 5 minutes, we're going to ask that all students report back to their first period class. When you arrive in class, you will get the progress report, which has all of the marks, all of the classes that you are in.
I just throw this out though. Wouldn't it be that difficult to sort them by fourth period?
That's true.
Parent-teacher interviews, and we hope that
Like instead, I'm losing 20 minutes of teaching with you guys. And I resent that. Are you still recording?
any student who is co-opting.
Yes. Whatever, I stand by it.
What? He's still recording and he goes, I resent the fact that I'm losing 20 minutes of teaching time.
I do. I do. I resent it. And I'm going to delete that portion of the recording.
That's a good idea.
Because I'm a
Keep your job.
I am. I'm fundamentally a coward.
City of Wellenberg.
You lost me.
Okay, they have the word cow on all of the, Welland signs.
Oh.
Okay, so you guys are. Was that right now? The impression I got was that was right now. In about 5 minutes. Okay, good. So we can do this one question. Okay. Normally I'd give you guys a bit more time to work this out individually, but not going to happen. So cosine of A in this case, and I resent it. Don't you doubt it. What do we have up top? I don't get mad. I get even. That doesn't even make any sense, but whenever I said 3.1 squared.
Square.
By the way, if I had written this 4.3 squared plus 3.1 squared, would that matter? No, order doesn't matter in addition. Minus 5.9 squared. But it is important that the one we subtract be 5.9. Good. On the bottom? Yeah.
3.1 times 4.3.
All right. And when I do that, I get a cosine of A. That is what? She lives. Oh, my goodness. I was worried. Oh, very in just a minute. What do we get when we do this? I predict it's going to be 0 point something. Bold prediction.
No clue.
Ah, you skipped a step, and I'm proud. Nothing wrong with that. Okay, if people did the cosine, what'd you get? 2516. Great.
Negative for you?
And then when you cosine,
Okay.
and that's important. So that negative matters. That negative matters. You guys, we haven't talked about this yet because we've never done cosine when the angle's bigger than 90. But guess what? When an angle is bigger than 90, its cosine is negative. And that's okay. You can work with that cosine. You're still going to take the cos inverse. But just if you take the cos inverse of that number that's positive, it'll give you the wrong answer. You got to make sure you put the negative sign in there. And if you did this in one step, it wouldn't have mattered. But bet you got an angle bigger than 90 degrees.
Yeah.
Yeah. So what's this work out to when we take the cos inverse? 104.6. Cool. So it is no problem to do it in 2 steps. Just make sure if it's negative that you treat it like a negative number. All right. Guys, have a wonderful day. Be kind to one another. Don't do anything that, let's say, Sarah wouldn't do. And head off to your first period classes.
All of the answers are on this sheet. Can I just toss this?
Sorry?
All of these
I'd like you to write
answers.
the answers on that. You don't have to show all the math or all the work, but I want to see your answers at least.